So in this video, we are going to make a game like this using Python, Opencv in a very few lines of code. So the first thing that we can do is to import the basic libraries, which are CV2, NumPy, and Mediapipe library, from where we'll be using the hands module. And then we will shorthand the Mediapipe hands module, as this will be required to detect the tip of the index finger in the game, which will basically control our bar. Now we can start the capture using cv2.video capture, and in the brackets we will write 0 as it stands for the camera. Now I think it depends on the system, or maybe I can be wrong, that the initial window that we get from Opencv, it is pretty small. I mean, you cannot play a game in that window until the window becomes bigger. So we will have to manually set that to a bigger and a wider frame, and these are the commands that we will use to enlarge the window of Opencv. So then we increase the window size to 720 as the height and 1280 as the width. And now we want to initialize the starting point of the ball, which is basically on the top of the screen. So we want to randomly pick an integer for the x coordinate as the initial point, and you can do it using the np.random.randint function. Now I'll take an integer between 200 pixel to 1000 pixel, as I do not want the game to start from the extremes, as you can see right now on the screen, from the red part. I want to start it from the green part. For the y coordinate, or yi in our case, we'll be having it as 0, as we are starting from the top of the screen. One thing I want to mention is that the frame layout of Opencv is something like this. So it's not like the first quadrant that we always imagine. It's pretty much like the thing that you're seeing on the screen right now. Okay, so after having found the initial point, we also need to set initially for the final point, because that will help us join the line and hence find the slope. So if the starting x coordinate, or xi, is greater than 600 pixels, that is, if the starting point is in the right hand side of the screen, we would want the final x coordinate to be on the extreme left hand side, and vice versa. The reason for that is we want to make sure that we have a high slanting, like as you can see in the image right now. But what if we do not do this? Then in that case, a situation can occur where the initial x and the final x coordinates are very close to each other, and the ball will just keep bouncing like this, and this will not be really good for the game, right? And now we have the most important part, that is the slope, and we will be using the basic formula y2 minus y1 divided by x2 minus x1, and the point coordinates are shown here. So we get 360 divided by x final minus xi as the slope. So you might have noticed that I have written 360 here and not 720, even when 720 is the height of the window. The reason is we have left the bottom 360 to let the Mediapipe hands model to detect the hand. So if we take the whole screen for the game, then to detect the hand will have to block the ball, and this will become very inconvenient to the player. And now we will want to specify the initial direction of movement, which is the direction at the beginning of the game. So this is how the game will begin, from the top to the bottom. So in the code, we define a variable vert and have the value down assigned. And this will be the initial direction of movement for the ball. Then we have the most important variable in the program, which is the skip variable. It is actually going to control the speed of the ball, which basically means the difficulty of the game. So we will initialize it to 10. Higher the value of skip, the faster the ball will move. So we initialize again a variable xcoord as xi, which we will see later in the video. Now we will instantiate the hands module and define some parameters. The first parameter is static underscore image underscore mode, which basically means, or rather assumes, the video to be stable frame to frame. So if you're not changing a lot of scenes in the video, just keep it to true. The second parameter that we are using is max num hands, and this should be set to 1, as this is only a single player game. Then lastly, we will have min detection confidence, and that is set to 0.5, which is basically how confident the ML model is that it has detected a hand. So 50% is okay for us. Now we will run a while loop and check whether the capture is open or not. If yes, then we enter and read a frame using this cap.read function. We then flip the frame. And this is important, otherwise when you move your finger to the left, the picture on the screen will show you moved the finger to the right. And to cater to that, just flip the frame. 1 here indicates flipping along the vertical axis. We then pass the frame to the Mediapipe hand detection model using the process function. The results variable will hold all the final landmarks for us. Another important thing is that we want to convert the frame image format from BGR to RGB, as Opencv uses the BGR format, but Mediapipe uses the standard RGB format. Now we need to move the ball, and for that we need to change the y coordinate of the ball. So if the ball is going down, that is if the value of the variable vert is down, we need to increase the value of yi. We increment the value by a factor of skip that we had defined earlier. Else, if the ball is moving up, we decrease the value of yi. Let me mention here that if you haven't already noticed, we move the frame and value of yi increases. And now that we have found out the new yi coordinate, we will be using this formula to find the new x coordinate. So yf minus yi is equals to skip. So yf stands for y final and yi stands for y initial, as in the last step here. And we rearrange to get this. So we will write xi plus equal to skip by slope. Now we have to check the border regions where the ball will bounce. Let us first deal with the cases when the ball will hit the ceiling or the floor. So if the ball touches the ceiling, that is if the value is close to 0, we will change the direction from up to down. Obviously, if the ball has come to the top, it means that it was going up and we have changed it to down. Else, if the ball has reached the bottom, then we set the vert direction to up. Now, we'll be looking into the case where the ball hits the side wall. So, if the value of xi goes close to 0 or close to 1280, which is the frame width, in this case, we multiply the slope with -1. This way, it will change its direction. Now we have both the xi and yi coordinates, and so we can actually redraw the ball on the screen. For that, we'll pass the cv2.circle function and pass the current frame as the first parameter. We then pass the coordinates of the center of the ball. Also remember to convert the value of xi to int, as the slope was a float, and so xi needs to be converted to int. Then pass the radius of the ball, which I have set to 15. Then pass the color of the ball, which I have set to green. And lastly, we want a filled circle, and so we pass the thickness as -1. So the ball is moving on the screen, as you can see right now. Now let's draw the bar which we will be using to play the game. So first we check whether we have found a hand or not. And if yes, then the value of results will not be none. Results.multihand.landmarks actually has all the coordinates of the points that we need. So first we shorthand the results.multihand.landmarks index of 0 as hn. Now we get the x coordinate of the tip of the index finger, and for that we write hn.landmark bracket 8.x. 8 is the location of the value. So I have explained these location values in the rock paper scissors video, and you can see it on the screen right now. You can focus on the tip of the index finger and how it has been labeled as 8. Then we multiply it with the width of the frame to get the real x coordinate of the frame. We do not need the y coordinate, as the bar will only be moving in the x direction. Now I have found that Mediapipe gives you the coordinates of a landmark even when the landmark is not present, like in the case when the index finger is not in the frame but all other parts of the hand is in the frame. So in the case, a negative coordinate will be given for the tip of the index finger. So we take that into account and we put a condition that the tip of the index finger can only move between 70 pixels from the left and 70 pixels to right, that is on the green line and not on the red line, so that our bar does not go out of the screen. Finally, we draw the bar using the cv2.rectangle function. As parameters, we first pass the frame. Then we pass the top left hand coordinate of the bar, as you can see here in the figure. The coordinate will be x coord minus 70 for the x coordinate, and x coord is the location of the index finger tip. And we want the width of the board to be 140 pixels, 70 in the left and 70 in the right. The y coordinate will be something more than 360, as the center of the ball reaches 360 pixels down in the y-axis. Due to the radius, the tip of the ball will come down to 375, and so we choose a value greater but close to 375. So we will have to write the bottom right coordinate as again 70 pixel right of x coord until 425. You can definitely play around with the values of the plank coordinates to alter its size. Lastly, we also pass in the color and the thickness. Now we are left with just one thing, that is to check whether the bar on the plank is below the ball, that is when it comes to the floor. So when the ball and the plank meet on the floor, the game continues, but when they don't meet, we lose. So here you can see the ball hits the floor but the plank is not beneath it, and in this case the player loses. For this, we write y of I is greater than or equal to 360, or a condition like this one. Now this condition of xi being in the range x coord minus 120 and x coord plus 120 means the ball hits the plank. If you see, even though the plank length is 70 plus 70 pixel, that is 140 pixel, as mentioned in the rectangle function, we have taken 120 plus 120, that equal to 250 pixel. That is, we have 100 pixels extra. The reason for that is we want to go along and let the game continue when the side of the ball hits the side of the plank, as you can see here. Lastly, we again write print lost and break. Then, to close, we show the entire frame and write the wait key condition and also break when the person presses the alphabet Q. To end the program, we just release the capture using cap.release and destroy all windows, and we are done. As you can see, we are able to play the game. I have implemented a very small version of the game. You can definitely add a lot of elements and functionality if you intend to make it yourself. If possible, how can I make my content more engaging, like the style of delivery or editing? It will be of great help, so please tell me. So please press the like and subscribe button, and thank you very much.